I will introduce our design process from hardware perspective. First, we decided to use Raspberry Pi as our main controller, and it's quite easy for us to add a feed-in trough with a step motor. Next, a camera was connected to achieve the live stream function. A light stripe and a water pump was also added to help improve our feeding experience. And we chose a power supply to convert high voltage AC to 12 voltage DC for our system. Moreover, we put a dual delay between power supply and peripherals so that our customer can control them on their phones. Last but not least, a TDS and temperature sensor was added to monitor the environment for fish.
There are three main modules in our project: remote control app, Raspberry Pi function design, and Raspberry Pi modules design and assembling.
So, about our fish food trough, we chose to use 3D printing because it allows us to achieve higher requirements. We actually made several versions. The first version was very simple, consisting of a perforated cap plus a motor. This is just to make sure there was a working version. The second version we get the idea online. It is from the version we started to use 3D printing. This version ensures that the quality of the material and the amount of each serving is relatively stable. But it also came with the downside of an over-large amount of food per serving, and it is not easy to fix it on the fish tank as well. So we had our final version, which fixed all previous problems. The motor embedded in the slot at the bottom of the cap will rotate the turntable under the cap, and a certain amount of fish food would be dropped at each rotation. And here's a short video of how we first get this version to work.
For water temperature and the quality part, our product has a heartbeat function that repeated every minute. It will collect data from Arduino and refresh the information on the app. How Pi and Arduino communicate is start with Pi that it sends a flag to Arduino first and end with Arduino's back flag.
We are using MQTT protocol to send the environmental information like temperature and total dissolved solid from Raspberry Pi to MQTT server, then send to our mobile app. We can also send command from mobile app to MQTT server, then send to Raspberry Pi. For example, here we can turn on the light, we can turn on the auto fit. The message can be viewed in the console window. Also, we can set up the auto fit time. We can see the auto fit time set up at 9:28.